Our topic is Karnaugh map, and simply it is written as K map. K map is the pictorial form of a truth table. It consists of number of squares. Each square represents a min term. So each square is representing a main term in the figure. For example, the first square represents the main term m0, which is equal to ab complement. Similarly, the second one represents main term m1, and this main term is represented by a complement b, and so on. So in this way, all the four squares represents different min terms. The K-map is used to simplify a Boolean function. Now, if a Boolean function consists of two variables a and b, then the number of squares of a K-map is 2 raised power 2, which is equal to 4. So we will draw a K-map having 4 squares. Now we are taking an example, and in the example we have a Boolean function which is equal to a complement b plus a b complement, and in this way we will draw a true K-map having 4 squares, and the first square having 0. Similarly, the second square has 1. Similarly, 1 is in the third square, and again 0 is in the fourth square. So the 1 which represents a main term in the Boolean function a complement b and a b complement. So now we will consider the adjacent squares. If two squares are adjacent, then we can combine them, and the adjacent squares are defined as the two squares are said to be adjacent if only one variable changes, if we move from one square to the other. Clearly, in the K-map, we don't have any adjacent squares, so we cannot combine them. So the function remains as it was before. So the given function remains the same, which is f, which is the function of ab, is equal to a complement b plus a b complement. Now we will draw its logic diagram. In the function, we need a complement, b complement. So we draw 4 lines. First line is a, and then we connect inverter with this line, and we have a dash. Similarly, one line is b, and if an inverter is connected with it, then we will be having b dash. So in this case, we will need 2 AND gates. First AND gate has inputs a dash b, so we connect 2 lines one from A dash and the other from B, and the AND gate gives us a term or ANDed term. Similarly, another gate, it has two inputs and one line is drawn which is connected with the line A, and the other line is drawn which is connected with the line B dash. So again we will have a term and a term. So these two outputs of AND gates are connected with the inputs of an OR gate. So the OR gate will give us the same function, and the function of the OR gate is to give us two terms, and addition of the two terms we will get at the output. Then we have three variables K map. Because the variables are three, therefore the number of squares in the K map will be 2 raised power 3, which is equal to 8. Now we draw a K map having 8 squares. Now different squares are represented in the figure. The first figure represents the minterm M0, the other square represent M1. Similarly, another square represent M3, then M2, then M4, M5, M7 and M6. These all squares are labeled 0, 0, 0, 1, 1, 1, 1, 0, and in the vertical direction we have 0 and 1. Now we have three variables x, y, z. So again we draw the truth K map having different terms. M0 is equal to x dash, y dash, z dash, and this term is written by keeping in mind the rules to write the minterm. Similarly, other minterms are written in the different squares. So if M0 represent the term a x dash, y dash, z dash, and it is corresponding to the binary code 0, 0, 0. Similarly, M1 is the minterm corresponding to the binary code 0, 0, 1, which represents the decimal number 1. Similarly, M3 is the minterm corresponding to the binary code 0, 1, 1, which represents 3 in decimal. So we have M3 and so on. Now we take example. In the example, it is written as simplify a Boolean function f, function of ABC is equal to a dash, b dash, c dash plus a dash, bc plus a, b dash, c plus abc. Now we draw K map of 8 squares, and then we will labeling these squares by 0, 0, 0, 1, 1, 1, 1, 0 along the horizontal direction, and along the vertical direction we will write 0, 1. Now we have three variables a, b, c, and the different minterms given in the function are 1 is written in the first square which has minterm M0. Similarly, 1 is written in the third square which represent the minterm M3. Similarly, 1 is written in the square which represents the minterm M5. Similarly, M7. So we have different ones in the different squares depends upon the terms which are given in the function. Now we will simplify it. So we have adjacent squares. So these adjacent squares can be combined to simplify the function. Now the two vertical squares are combined, having 1, 1. So by combining, we will be having term. So in order to write the term, we will see that along vertical direction, if we move from one square to the other square, the variable a changes from 0 to 1. And therefore, this variable is neglected. Now the variables which do not change are b and c, and the states of the b and c are 1, 1. So we will write bc. Similarly, the horizontal two squares are combined because these two squares are the adjacent squares. So by combining, we will write another term AC. Now we will see that one which is in the first square, it cannot be combined with any other square because the two squares must be adjacent squares. So this one cannot be combined with any other square. So we will write its term as it is a dash, b dash, c dash. Now we will draw its logic diagram. In the logic diagrams, because we have three terms, so we will draw three AND gates, and the first AND gate, it has inputs a dash, b dash, c dash, and the AND gate will give us a term which is in the ANDed form. Second AND gate, it has inputs b and c, so it will also give us ANDed form term. Similarly, the third one, it has inputs AC, and this will give us ANDed form term. So all these three terms are connected with the input of the OR gate, and in this way we will get the plus sign between the two terms. So at the output of the OR gate, we will get the required function.